Good afternoon, one and all. Hope I'm audible.
Yes, ma'am.
Prasad, am I audible?
Yes, ma'am.
Okay. Good afternoon, one and all, for this continuous CME program, which we are conducting as a part of this Laboratory Professional Week. And today we have a talk on flow cytometry by Prasad. He is a senior technician from Medical College Hospital. So this year we have newly introduced a flow cytometry, and he'll be making us learn about the techniques and all. Okay. Welcome, Prasad.
Thank you, madam.
You are sharing the screen.
Bharat Kumar Reddy, madam.
Bharat is sharing the screen. Okay. Bharat, is it Bharat Kumar Reddy or Mahit Reddy?
Mahit Reddy, madam. అదే కదా వచ్చేది భరత్ కుమార్ రెడ్డి బి మహిత్ రెడ్డి ఉంటది వన్ సెకండ్ మేడం
భరత్ కుమార్ రెడ్డి
భరత్ కుమార్ రెడ్డి
Okay, I'll do it now.
ఇక్కడ ఉన్నావు కదా ఇదే ఇది నేను ఆగిన
Yes, you can start now.
Okay, madam. Good evening, one and all, and congratulations from all the participants and who have joined in this program and who have celebrated all over the India, the National Medical Laboratory Professional Week very well. Today also we have conducted a blood donation camp in our hospital. We are happy to share all these programs, and thanks to Dr. Ratna Madam for giving continuous support. So actually today the program is scheduled for IHC. So little bit I will give for 5 to 10 minutes talk on this flow cytometry. This is the flow cytometry basics and applications I will explain. Introduction of flow cytometry. Flow cytometry is a powerful and versatile analytical technique used to examine and quantify the characteristics of individual cells or particles in a fluid suspension. It provides valuable insights into the physical and chemical properties of these entities, enabling researchers, clinicians, and scientists to study a wide range of biological phenomena. Flow, the motion characteristics of fluid. Cyto, combining of cells or cells. Metry, measurement. Hence, measurement of physical and chemical characteristics of cells or in general biological articles is known as a cytometry. When such measurements are performed while the cells or the biological materials pass in a fluid stream across an illuminated light path, the process is known as flow cytometry. Instrumentation and technology. Instrumentation technology are fundamental components of flow cytometry that enable the accurate and efficient analysis of cells or particles. The key elements of flow cytometry instrumentation include the flow cytometer itself, lasers, detectors, fluidics, and data analysis of software. Two fundamental types of signals are detected in flow cytometry: light scatter. The cells or particles scatters light in different directions when they interact with the laser beam. This scattering provides information about their size and internal complexity or granularity. Another is forward scatter, measures the intensity of light scattered in the forward direction correlated with cell size, while side scatter measures the intensity of light scattered at orthogonal angles, providing information about cell complexity. Principles of flow cytometry. The principle of flow cytometry is based on the analysis of cells or particles as they flow through a narrow focused stream in a fluid medium. This technique combines the principles of fluid dynamics, optics, and fluorescence to characterize and quantify the physical and chemical properties of individual cells or particles in a high throughput manner. The main steps involved in flow cytometry include sample preparation, fluidic system, laser light source, light scatter detection, fluorescence detection, and data analysis. Flow cytometry has three main components, as we already told, that fluidics, optics, electronics. Fluidics transports particle in a stream to the laser beam for interrogation. Optics. It consists of lasers to illuminate the particles in the sample stream and optical filters to direct the resulting light signals to the appropriate detectors. Electronics. The electronic system converts the detected light signals that can be processed by the computer. Sample preparation. The sample to be analyzed is prepared by suspending cells or particles in a fluid medium. The sample may require prior processing such as isolation and enrichment to obtain the desired cell population for analysis. Additionally, cells or particles of interest are often labeled with fluorescent markers such as fluorescently tagged antibodies or dyes that specifically bind to particular cellular components of molecules. Fluidic system, already I told that the prepared sample is injected into the flow cytometer where it flows as a narrow focused stream called the sample stream. To ensure accurate analysis, the flow cytometer uses a hydrodynamic focusing system which aligns the cells or particles in the single file as they pass through the instrument. Requirements, you can see the requirements are CD labeled markers and the Falcon tubes, which routinely we will use different tubes, and we will use for the this preparation. Falcon tubes we will use, pipettes, tips. These are the basic and vortex mixture. These are the basic requirements are needed for that. And you can see this is we are having in ESIC Medical College Hospital, Sanat Nagar, Hyderabad is having BD Fax lyrics. It is a 10 colored flow cytometry. So we are running as of now acute leukemia panel and a CLPD panel also, chronic lymphoid proliferative disorders. And anybody interested from other states also, you can contact us and we will give the live demo to all of them. There is no issue. And some more points regarding forward scatter and side scatter already I explained. Data analysis, fluorescence detection. If the cells or particles are labeled with fluorescent markers, the laser light excites these fluorochromes, causing them to emit light at longer wavelengths. Multiple detectors are placed at specific angles relative to the laser beam to capture the emitted fluorescence. Each detector corresponds to specific emission wavelength, allowing for the simultaneous analysis of multiple fluorochromes in a multicolor flow cytometry experiment. Data analysis. The emitted light, scattered light signals are converted into electronic signals and collected by computer. Advanced software is used to analyze the interpret the data, enabling the identification and quantification of different cells population based on their size, granularity, the fluorescence characteristics. You can see here the cells, neutrophils, lymphocytes, monocytes are differentially, it will show on the data which we acquire after the acquisition of the sample. We can observe all those things clearly in the computer. Applications of flow cytometry. Flow cytometry has a wide range of applications across various scientific disciplines, diagnostics, and clinical practice. Some of the key applications of flow cytometry include immunophenotyping. Flow cytometry is extensively used to identify and characterize different cell populations based on their surface marker expression. This is especially crucial in immunology and hematology study immune cells subsets, identify abnormal cells in blood samples, and monitor immune response in various diseases. Diagnosis of hematological disorders. Flow cytometry is a valuable tool in diagnosing and classifying hematological disorders such as leukemia and lymphoma based on specific surface markers expressed on abnormal cells. And we can do on this MRD, minimal residual disease. It will helpful for the leukemia patients. After they are getting the treatment also, we will see how the response is there. So we can use this flow cytometry for MRD and as well as MDS, myelodysplastic syndrome also. Okay, thank you. This is brief about the basic of this flow cytometry.
Thank you, Prasad. So the main application of a flow cytometry is in the hematological malignancy. So right now at our setup, we are doing for acute leukemias and
MRD, madam.
Minimal residual disease.
Yes, ma'am.
Yeah. Thank you, Prasad. Any doubts from the audience? This was just a brief overview about, because this is a newly introduced system and we are in the process of collecting the number of samples. So maybe for next year, we'll have a volume to speak about this. Is it?
Yes, ma'am.
Thank you. Any questions from the audience? Thank you, Prasad, for a crisp and informative talk on the flow cytometry basic principles. I think now we'll move on to our next talk.
Yes, ma'am. Praveen Ambadi will take over, madam.
Yeah. Welcome, Praveen.
Yeah, madam. Just a moment.
Good evening, ma'am.
Yeah, good afternoon.
Good afternoon.
You're going to share the screen by yourself or somebody else is assisting you?
I share myself, ma'am.
Okay, fine. So Praveen is going to say us about the immunohistochemistry basics and application. Yeah, it is ever, all-time hot topic. And anything we are learning about it, then definitely we need to have a more knowledge in the day-to-day practice. Welcome, Praveen.
Thank you. Good afternoon, everyone. Now, thank you, ma'am, to allow me to speak on that topic. So today's topic is immunohistochemistry basics and its application. Now, what is ISC? Immunohistochemistry combines immunology, histology, and chemistry. ISC is an application of antibody to tissue preparation for the localization of target antigen visualized using a microscope. ISC indispensable accelerator tool. ISC testing is an essential component of the pathologist evaluation of a tissue sample. It serves critical need in the patient care as the result from ISC testing often directly guide and treatment. Now, why ISC is important in a surgical pathology practice? It is used for categorization of undifferentiated malignant tumor like carcinoma, lymphoma, and sarcoma. Subcategorization of tumor, lymphoma, determination of sites of origin of metastatic tumor, that lung, GIT, and prostates. Detection of molecules that have prognostic or therapeutic significance. For example, ERPR, HER2 in breast carcinoma, and ALK1 in a lung adenocarcinoma. Basics of immunology. Simple principle is antigen and antibody complex. Immunohistochemistry is a technique based on the selective binding of specific antibodies to specific antigen site on a cell. Is a precise lock and key mechanism. What is an antigen? Any substance that can trigger the production of antibodies is called antigen. What is antibodies? Antibodies are the proteins called immunoglobulin. These are What are the cellular antigen can target? It's target on cytoplasmic, nuclear, and cell membrane. It is a flow chart where cell has a antigen on their surface. If putting the primary antibody, then label with secondary antibody, then add their HRP enzyme. After that, we adding their chromosome and make precipitation brown color formation. It is the first step of histopathology. Routinely, we are performing in our laboratory. When the fresh tissue will come, it will be get fixed. After it get processed in a various grade of alcohol, and after that xylene. After that, impregnate with the paraffin block, then section cut, and we can take that section on the coated slide, which is coated with polylysine glass slide. Immunohistochemistry will get performed in two ways, that manually and automated. In our hospital, we are performing in both ways. So here, for manual purpose, we need antigen retrieval. We need for that multi-epitope retrieval system for antigen retrieval. These are the instruments that we need: microtome, charge slide, DVAX station, micropipettes, measuring cylinder, and humid chamber where the reaction is. We need pH meter. We use a immuno wash buffer that for washing purpose whose pH is 7.4 to 7.6. And we have a different retrieval buffers, that citrate buffer whose pH is 6, EDTA buffer whose pH is 8, and trice EDTA buffer whose pH is 9. These are the reagents: trice EDTA buffer, immuno wash buffer, and reagent block pane we needed during the procedure. These are the primary antibodies and secondary antibodies, HRP and DAP chromosome. This is the flow chart which ISC is going on. After section cutting, we deparaffinize it, and further we perform retrieval, antigen retrieval, and then wash it, and then apply primary antibodies. After that, we are applying secondary antibodies. After that, we are applying enzyme over there, and finally we are getting applying chromosome and counter stain with hematoxylin, and finally we see such kind of result will come. First step of ISC, fixation. It's help to prevent elution, degeneration, and modification. When the sample is come as early as possible, we have to get fix it in a 10% neutral buffer formalin, which is preserve the position of antigen, preserve the secondary and tertiary structure of possible exchange, provide target for antigen molecule. Formaldehyde is preferred in every laboratory, that is 10% neutral buffer formalin. Second step, section cutting, deparaffinization. We cut a section on 2 to 4 micron on the slide. Charge slide required for that to mount the section, which provide adhesion to the section. Tissue are further adhered to the slide by baking 60 degrees Celsius in incubator. Deparaffinization. Tissue is treated in a series of xylene and alcohol to remove the paraffin bags. Step 2, antigen retrieval. Multi-epitope retrieval system we are using in our laboratory, which is retrieve the section under steam pressure for 20 minutes, which is a constant temperature over for 20 minutes. Allow solution to cool at room temperature. Antigen retrieval method break down cross-link between the adjacent protein and expose antigen site and increase the stability of antibody to antigen, allowing antibody to bind over there. After that, we are using a peroxidase blocker, which applying on the section, which is reduce the background staining and block endogenous peroxidase. Applying primary antibodies. We are using two type of antibodies, that is polyclonal and monoclonal. The polyclonal antibodies are the large complex antigens, may have multiple epitope and elide several antibody types. And the monoclonal antibodies are antibodies specific for the single epitope and produced by a single color. Primary antibodies are used to detect protein in a cell within a tissue section. Now, secondary antibodies and HR. Antigen antibody conjugates are visualized by use a label, enzyme that produce a color precipitate in the presence of substrate are used as a label. Label are the horse red peroxidase, that enzyme we are using in our label. After that, that enzyme produce color precipitation in the presence of specific substrate. Most widely used label is peroxidase. Peroxidase are dark brown precipitate when diaminobenzidine is added. Alkaline phosphatase is also used and produce either red or blue precipitation. Counter stain. Provide a contrast to the primary stain. Most commonly, counter stain is hematoxylin, which is used in every laboratory. After that, the result will look like that. Positive nuclear positivity. The result are the reaction is show like in three way: nuclear, cytoplasm, and membranous. First of them, a nuclear positivity look like that. Cytoplasmic positivity and membrane positivity. ISC controls. We are using in control with every slide. Positive control. Cell or tissue that are known to contain a specific antigen. Detect false negative due to fixation or process. It is used to validate the protocol or procedure. Negative control omits of primary antibody with the same tissue and procedure. Used to detect endogenous biotin and peroxidase activity. How to overcome practical difficulties of variation in ISC staining related that human error will get minimized if we are going to automation. Standardization and validation of ISC. Why we needed to validate ISC markers. Reagent and antibody may be different origin, composition, and concentration, or sensitivity or specificity. Can't rely on the manufacturer. We need to test them on in-house tissue before start to use them in diagnostics. Well, strict journals say if we are not properly following the procedure in our laboratory, so we can give a false positive or false negative result. In this article, there sometimes HER2 will located test were retested on a central laboratory. They found that 14 to 16% false positive and 18 to 23% false negative test. Like that estrogen receptor, when the locally tested cases were retested at the central laboratory, 1.8% will be false positive and 70% false negative. So precaution should take properly during the ISC staining. Avoid misleading ISC. Use optimal methodology, antibody incubation time retrieval, and proper reagent preparation. Quality control, use appropriate control. Interpretation of immunohistochemistry to recognize the brown color cell in the right context. Everything that looks brown is not a positive. All that is brown is not a real. Background staining false positive, including artifacts. Problem of false brown background staining due to hydrophobic and electrostatic interaction, endogenous peroxidase, endogenous biotin, antigen diffusion, antigen retrieval, polyclonal antibody, and necrotic tissue. The background staining are such type. Antigen diffusion. Artifact in ISC. Ages and trapping artifacts, discrimination artifacts, bubble artifacts, drying artifacts, artifacts of poor fixation, precipitate dab artifacts, biotin artifacts. Age and trap artifacts look like that. Crust tissue artifact, deposit artifacts, drying artifacts. What we do for that, we don't want such kind of artifacts in our laboratory. So we get troubleshoot of that. Weak or non-staining, over-staining or non-specific or high background staining. ISC troubleshooting for weak or non-staining. Inadequate deparaffinization. It is one reason for weak or non-staining. So the solution is that to deparaffinize the section for longer or change the fresh value. Inactive primary antibodies. So replace with a new batch of antibodies. Antibodies do not work due to improper storage. If you are not storage as their recommended temperature, so maybe such this reason will come effect on our staining. So make adequate antibodies into the small volume and store in a freezer, and avoid to repeat freeze and thaw cycle. Antibody concentration was too low. So increase the concentration of antibodies or run a serial dilution test to determine optimal dilution. That's Q, the base signal noise ratio. Inadequate antibody incubation time, it is also one reason. So increase the antibody incubation time. Inadequate or improper tissue fixation, it is also one reason. So for solution is that to use freeze fixative. Tissue over fixation or under fixation. The solution is that to reduce the duration of post fixation or perform an appropriate antigen retrieval procedure. Incompatible secondary and primary antibodies. So solution is that to use secondary antibodies that will interact with primary antibodies. Inactive secondary antibodies or other reagent replace with a new batch of reagent. Inadequate substrate incubation time. So solution is that to increase the substrate incubation time. Antigen retrieval step performed incorrectly using wrong timing. So solution is that to antigen retrieval step performed correctly at a proper temperature and time. Reagent apply in wrong order or step only. Solution is that to check note or procedure use properly. Overstaining and high background staining. There is a one reason is that the concentration of antibody was too high. The solution is that to reduce the antibody concentration or perform a titration to determine the optimal dilution for primary and secondary antibodies. Incubation time was too long. Solution is that to reduce incubation time. incubation temperature was too high. The solution is that to reduce incubation temperature. Substrate incubation time was too long. Section dry out. Solution is that to reduce substrate incubation time, avoid section being dry out during staining procedure. ISC troubleshooting, tissue lift off. So slides were not positively charged. So use positively charged slide properly, or those are tissue was not baked properly. That is also the reason. Tissue lift off during staining procedure. Tissue contained too much of fat, and tissue not processed properly. So these are the reason when we are mounted tissue on the slide. So during the staining procedure, it is the lift off. So please careful that. Thank you. Thank you.
Thank you, Praveen, for
Thank
an
you.
elaborative talk.
Thank you.
Was very nice because after the automation has come, we have forgotten about the basic techniques like how we do and all. But it is rightly interpreted, and the pitfalls and the problematic areas also you have highlighted, and the how to fix that problem also you have set a solution. Very nice. Any questions from the audience? Any questions from the audience? So, Praveen, one question from my side, like main tissues which are troublesome in IHC in your personal practice.
So, ma'am, when we are not fix it properly, ma'am, means we are delay of fixing that tissue. So, at a time of section cutting, it's difficult to take on 2 to 4 micron. The wrinkles will come, and that may be one reason which during the staining procedure it may be get lift off, or it may not get lift off. So some background staining here process properly, so antigenicity are maintained properly, and the remaining staining procedure smoothly. We give a correct result over there.
You have given an example of breast markers. So we have encountered the similar when we were doing a manual in our center. So do you have any similar experience with you?
When we are performing breast panel on ISCM, so many times there is too fatty tissue will come for, along with tumor. So if we are remove that fatty tissue and give only a tumor for staining, so that will be that give a good result to us.
The staining pattern, especially with reference to HER2, is there any differentiation you noted in your breast panel markers?
No, ma'am.
We have noticed quite a few at our center in comparison to the Nizams. Fine then. Any question from the audience?
Yes, ma'am, I have a question.
Yes, please.
Ma'am, how to validate the markers actually? I am from
You're from which
ESIC
place?
Joka.
You're from which place? Please introduce yourself.
ESIC. Okay, ma'am. I'm a lab technician working in ESIC Joka Hospital. That is Kolkata.
Okay.
Okay. We are using Leica Bone Max actually. It's automated.
Okay.
So how to validate the markers, ma'am? Actually.
How to?
Validate the marker.
How? Sorry, I didn't get your question.
He asking how to validate the marker, ma'am.
How to identify?
Validate the marker.
Validation.
Validation. Yes, Balakrishna, this question is for you.
Yeah. Actually,
Sorry,
whenever we receive fresh batch of antibodies, we have
Okay.
to validate. That means we have to take a already known positive cases of that marker slides. We have to take and we have to run. And after when pathologist confirms that staining was good, then that primary antibody is getting taken as validated.
Okay. Like that only.
Yeah, that's it. Each
Okay.
and every marker before running on patient samples, we have to do once with already known marker, known positive markers.
No, sir. We are
And after
already we are using
confirmation,
the
we have to
positive control,
validate.
na? No.
Yeah.
No. We are already using the positive control. So what is the need of validation then?
No, actually, it is
So-
the principles as per some guidelines will be different. In foreign countries, as per their guidelines, this many slides, not only single slide. Some guidelines tell that it will take, should run for 10 slides. Some guidelines tells that we have to run at least 20 slides.
Mhm.
So
So
guidelines will be there.
is it good to look the clones and the source of clone like the mouse monoclonal or rabbit monoclonal like that before using? Actually, we are following the NODQC guideline. So in the NODQC, whatever the listed clone,
Never.
so very few like the lambda and kappa, they are always polyclonal mainly using. So many times they are supplying that monoclonal also. So it is good to use the monoclonal for lambda or kappa.
Monoclonal have an advantage over the polyclonal.
Polyclonal,
Yeah, correct. But for particularly lambda and kappa, we're using the polyclonal, na, light chains. So
yeah, that is your lab preference. If you are able to get monoclonal, better to go for monoclonal. If there is no chances of getting monoclonal, means when there is no option, you should go for polyclonal.
And about the source like the mouse or rabbit. So what we will prefer, mouse or rabbit? I think.
Yeah. Actually, they will it will be based on the companies. In Path Institute and Roche, Ventana.
Yeah, some company they are making the monoclonal.
Yes.
Okay.
Some companies they
Some
are
they are providing the
rabbit.
rabbit. Okay. So which one is good, rabbit or mouse? Or both are insignificant?
Actually, as per my knowledge, the source of all these companies' main primary antibody will be same only. These companies will purchase that main concentrated sample from the vendor and they will make dilutions. Nowadays, we are getting all ready to use antibodies only, no? So they are based on their own requirements. They are preparing the liquids with their own concentrations. In the market, as per my knowledge, Ventana is providing very high concentrated diluted antibodies as per my knowledge, in my experience. After that, this Path Institute, after that, DACO is good. Then Path Institute.
Nowadays, DACO is not invoicing any type of markers in
they
India.
are having issues
because some
importing
licensing issue or somewhat. And even Leica is not giving some markers. Only 24 are in our India.
In our state nowadays, Ventana is better. After that, Path Institute is they are providing well nowadays.
Like Cellmark and other, they are providing.
Yes.
But one more thing that on some markers they are mentioned their research use only, and not as IG. So we can use
some markers
use that
like IDH and ATRX, that type of markers. So they will mention this is not for patient results. They are not available in market for diagnostic purpose. We have to use them only for some publishing papers and research purpose only.
But after validation, we can use that research use only labeled markers.
Yeah, we should. There is no option. No, we should use it for our patients also. But they will not take responsibility if any adverse effect of report from patient side. They won't take. They will mention before only. No, it is only for research purpose like that.
Okay. Sir, I have one more question. Like when we're using the and high pH and low pH. Okay. So maximum markers using the in high pH, I think. Only few are using the low pH. And like the Hartinue and some other. So what is the basic of this? Why we're using the high pH only? Why not low pH? Or if you use the high pH, then what will happen?
You are telling about antibody pH.
So, sir,
No,
retrieval,
sir.
regarding retrieval.
Retrieval.
Antigen retrieval, we are using IPH only.
No, sir. There is two pH and one is low pH. Just now you have shown now that one is low pH 6.0 and one is high pH. There is 9.8.
No, we actually, as Praveen said, no, we have to all secondary antibody retrieval and everything. It is a matching. If we are taking one from one company means we have to take the risk.
No, I'm
So we
asking
have
about
to we are going as per protocol of the company only.
Okay. Okay.
In our center for all
So it could be
tissues,
like
we are using the CDTA buffer only at pH 9.0.
9.0. Maximum here is the high pH only, but except few markers, then everything that like the Hartinio.
For Hartinio also, we are using that pH only 9.0 only.
9.0, is it?
Yeah.
Okay. But we are using low pH.
Okay.
I think in BondMax maybe it's adjusted like that.
Okay. Here for all tissues, we are using only one antigen retrieval buffer.
Okay. Thank you, sir. Thanks a lot.
Yeah, I think for HER2 and all, it is always a problem. Little bit results are not in consensus in the various institution studies. So that is the reason why, especially HER2, we go for immunofluorescence, and we have a HER2 dish also in our center at Super Speciality Sanat Nagar. Okay, that is one parameter, as you said. So the high and the low pH, what Praveen has said, and you have a doubt, and what Balu was trying to explain is, maybe at the lower end, see, you got a range, that at the lower range, it could fall into. That is the reason why there are inconsistent results with the HER2. So that is the reason why various studies have been done on this, and now we have different concept. HER2 also like positive, intermediate, and a weak, and HER2 low. And in few cases where it is indeterminate and weak, in that immunofluorescence, it shows something else. When it comes to amplification studies, it shows sometimes amplification is seen, sometimes it is not seen. So it is unexplored area. It is still under progress. We can't comment on that right now, I think.
Right, ma'am.
Any other doubts from any questions from the audience?
Yeah, ma'am, I see the subject that there is many doubts and questions. So I think
please feel free to ask. We are here for that only.
No, this is a nice seminar, ma'am, organized by other team.
Yeah, actually, our technicians, the technical team, all are very enthusiastic and hardworking. They have put in a lot of effort, We just have come up with an idea. Let's start immunofluorescence. Let's start immunohistochemistry. But the hard work lies behind with these people. They put in every effort to standardize this. We just report it positive, negative. This is positive. This is negative, and all. But with utmost dedication and hard work, these people are preparing and giving us the slides, and we are able to serve.
Yeah, ma'am, correct, ma'am. Even in manual, it is very difficult, ma'am. And batch was doing, but I'm fortunate that we get this one, BondMax. So
yeah, no problem. If you see, we do get samples from Bangalore and Kerala also. If you wanted any cross verification of your samples, also you can courier us to Sanat Nagar Super Speciality. So we'll help you out with that also.
Oh, nice, ma'am.
Yeah, here we are having fully automated Roach Ventana.
Okay, that is good. Ventana is always superior than other.
Yeah, we are working. Here samples almost from Karnataka, Kerala, and Telangana samples. We are running on Ventana only.
Okay, nice. Ventana is good, sir.
Yeah.
And many molecules are FDA approved in this. So even for the research work and all, like you have a residence and you got a postgraduate in your institute, anybody want to go for a collaborative project also, you can contact us. And any cross verification and cross check of your slides which you are doing, that also you can send. Please convey this. Yes?
Like Equus type, no, ma'am?
Not EQUAS. EQUAS, you have to enroll it other institute. This
Okay,
is
okay.
just for confirmation. Some slides, when you feel it is doubtful and all, for intra-institutional verification, you can send us.
And for any rare antibodies like cases, ma'am, so you can send there.
Yeah, anything which you have a doubt. So it's a matter of courier charges, but at least you'll have another pathologist opinion and another machine work you'll be able to appreciate. No, so please make utilize of this and convey this message to your pathologist. So hope
Correct.
it's clear now. Okay, we have come to the end of
Okay,
the
ma'am.
session, and if there are no more doubts, I think thank you one and all. As a part of this laboratory professional week, this year also successfully we could complete 5 talks. So all the speakers have put in their efforts to make this program successful. Thank you one and all for joining this.
Thank you, ma'am. Thank you, ma'am. This is a nice session.
Thank you.
Okay.
Thank you, madam.
Yeah, thank you.